Welcome to the Rise Inside podcast, hosted by Justin Starbird and powered by RISE Robotics. Listen as host Justin talks to experts from the RISE team about topics relating to mechanical engineering, industrial design, commercialization, and innovation. True collaborations work when ideas are integrated at inception to solve significant problems. Rise Inside brings together how the team continues to work with great folks to commercialize ideas. You're listening to the Rise Inside podcast. Here is your host, Justin Starbird.
Welcome back. My name is Justin Starbird, and today I am at RISE Robotics with CEO and founder Arron Acosta. Arron, thanks for joining me.
Good to be here.
Man, this is so exciting to not just learn more about RISE, but tell more people about RISE, what you do, and where you came from. So with that, Arron, tell me, what is RISE?
RISE is a technology industrial company that is making zero emission heavy industrial equipment with a new mechanical invention. And specifically, it replaces hydraulic cylinders for pushing and pulling. It's pretty technical stuff. But the gist of it is by getting rid of the most inefficient element in the heavy machinery, which is currently wasting that energy into heat by churning a fluid. Instead of the fluid, we have a direct mechanical system that uses less energy. It also moves with more precision control, and it makes it possible to make these heavy industrial machinery zero emission more affordably.
We're right outside of Boston. In the background, we hear, construction. We're in the shop at at our corporate office. And you can hear stuff is happening, and it's so exciting to know that, or to realize that, we had the ability to actually, change several industries by implementing this technology.
Yeah. And I imagine in, the future, the very near future, 2030 even, that, the construction equipment that's moving earth, would be quiet and nearly silent. Mm-hmm. And instead of belching black smoke into the nearby communities, it would be zero emission and running on electricity. Also, garbage trucks wouldn't wake you up in the morning.
Right.
And, it's a long list of heavy industrial machinery, like the forklifts that move the containers in which your goods show up at the ports, as well as, the food and beverage that gets delivered to your local convenience store or restaurant or wherever you're picking up your favorite food and beverage. Mm-hmm. Pretty much everything gets picked up, moved, and set down many times. Right? If you think about all the stuff that is in our world, it gets pulled out of the ground. Mm-hmm. Right? There's a machine that does that digging. It gets loaded up into another machine. That machine is doing loading. And it gets touched over and over and over again as it gets bundled and bundled again.
It moved through the whole supply chain.
Yeah. And I mean, if you follow it, right, it comes from little tiny bits and it gets bundled up into these really big containers, and then it gets broken back down again into smaller pallets and then brought to ultimately, to you.
Right. I mean, absolutely. Well, I think about this industrial space, and it's not sexy, and you kind of graduated from MIT and it's not it is very technical in nature, but it's also really industrial in nature. So it's not your typical startup here at RISE. How did you get started? How are you hey, I want to get into hydraulics and eliminating them?
So we had a purpose to make the future of human motion just better, right? Mm-hmm. So stronger, faster, lighter, draw less power. And
are you thinking biometrics, or are you thinking
So we're thinking of what's the pinnacle of vehicles, right? And a well-made vehicle comfortably holds a human, mm-hmm. and it empowers them to move around faster and haul things with them. And the frontier of human motion is wearable, mm-hmm. right? So if you had effectively all the benefits of a car, but packaged in the form of clothing, then that would be a space age, like space suit or an exosuit, right? You can imagine like putting on boots, pants, belt, and jacket and backpack, and that wearable suit would make it so you could lift heavy weights, leap with large bounds, and generally be superhuman. So we formed RISE actually to make that possible, and we set out to make the technology that would make that possible. And so we first started actually building human,
like an Iron Man suit.
Yeah.
Okay.
We were building harnesses.
Yeah.
We were building ways to store that energy in a spring. So we built new types of springs. We built ways to then deliver that power to motion with what's called an actuator, of which, one existing type is hydraulics, but there's lots of different actuator technologies, because it's a really hard job and it winds up being very specific to each category. We also make clutches and, generally all the technologies necessary to make advanced human motion. And in the middle of that journey, we realized that new technology and new business is two really hard things. And so we lowered the difficulty by taking the technology that we had developed and searching for a large existing market where we could have a really big impact on the planet.
Sure.
And so we just introduced the most valuable technology, which is our actuator. Since, as a brief aside, if you think about like what percentage of the system is the spring, it's less than 1%.
Sure.
Like a car, for example. Or if you look at what percentage of a car is actuation, it's about half, right? So one of the key technologies in vehicles or motion making equipment is how do you deliver that power? And it's even more important when you think about where does that power come from and how does it affect the waterfall, if you will, right? So like, if the job to be done is to move goods, then the knock-on effects are effectively how much fuel you're using, or how big your battery is, or how big your gas tank is, or like how long is your range, or how many hours can you operate for. So by making a better actuator, we found that we could also effectively make a better battery. And so all that is a way of saying that we introduced our actuator to all the different motion making industries. And the ones that really had a need are the ones where material handling that has battery problems found that there was a lot of value in solving their battery problems and making their machines run longer. And then we've additionally found that there's a lot of aesthetic benefits to making quieter machines and then making them more productive through higher precision and higher speed. And so we essentially just opened ourselves up to the possibilities of taking a profoundly disruptive new technology and just introducing it to everybody. And so we just introduced it to all these different material handling, construction, agriculture, and generally heavy industrial machinery.
To see who bit, or
we want to see who cared, who bit, right? What's out there? What are the problems to solve? And it wasn't just hydraulics at first. I mean, the other competitive actuation technologies included cables, screws, rack and pinions, crank and sliders. These are all in the mechanical engineering world, there's a whole book called, I forget the exact title, but it's like 409 or 509 mechanical motions, right? And there's a pretty specific list of all the ways to deliver power.
Sure.
And it's complicated, it's vast, and it's usually very specific. So, trying to figure it out on our own was pretty much an impossible analysis.
So how did,
so we didn't, and the short answer is we never thought we would end up in hydraulics for heavy machinery.
Right.
Actually, early on, we thought that hydraulics were the hardest, biggest thing.
He wants to know how we're doing.
I guess. Yeah. Cool. So, yeah, we actually we were focused on those smaller versions. At first, we were looking at like pneumatics or air cylinders instead of fluid cylinders. We were looking at screws, right? But these are smaller scale things.
Now, was this when you were still trying to build the Iron Man suit, for lack of a better term?
We stopped working on the Iron Man suit in
pretty early on.
Yeah, I would say we did that for the first year.
Yeah,
and then we started looking at what can we do with the technology we developed.
Yeah. Well, walking through the shop today and seeing, it's not just iteration 1, through 10. It's like 1A, 1B, 6C.
And I didn't even show you the springs and the clutches,
right.
or the harnesses, or the boots with belts. Right? Like, some of those are in deeper storage.
Right. But it's quite a feat to not just think of how to solve the problem, but then engineer solutions for each point along the way. How did that? Tell me about the team and how you started. Going from one point where you were like, "Hey, this would be pretty cool to do right out of school," and then seeing the need in material handling and in the industrial sector, and then be like, "Holy cow! Now we need people that can actually do all this."
Yeah. So the beginning was a discovery period with just play sessions and me, and we were looking at exosuits, and we were looking at the markets for them. So there's medical, military, industrial, and then we believe that recreational or sport is actually the best way to go. And then we added to the team by bringing on Tomas Seth, a mechanical engineer from MIT, who very pragmatically would design and build and test right alongside Blake. And then we were looking for applications for the technology at that point. So still in a discovery phase, but now with a new hypothesis that we could put this in lots of different machines. And so we just started essentially showing what it would look like in those machines, and then seeing if we could find the value there. And then from that point, then we had a capability to conceive, design, and test our hypothesis around improving machinery with our new technology. We brought onto the team Kyle Delaquila from the Rhode Island School of Design to help communicate this visually and share this story about what we were doing. And so we're still in this discovery phase, just the four of us, for quite a long time, actually. I would say it was approximately, we started in 2011, we brought on Tomas in 2012, brought on Kyle in 2014. Yeah. Maybe 13. That's a good check. I think it's 14.
Yeah.
But,
still, that's, 7 years. To have the core group together, so having
a small team. So just the four of us. Yeah. And we had interns, we had some people come and go here and there. But really just the four of us, went at this for about 7 years until.
Now, was this like a night and weekend deal? You had jobs in between?
This was all day, every day. Yeah. Like just,
So where were you? Like what kind of space were you in or now we're in,
So it was just Blake and I, we were in, our third floor apartment in Cambridge, Massachusetts, in like a kind of rundown part of Cambridge, which is still very expensive.
Right.
To save on rent, we had turned our 2-bedroom into effectively a 3-bedroom, and just Blake lived in the living room. And the kitchen was our office and prototyping center.
Yeah.
So Blake would he was using heat guns and, equipment in the kitchen. And, I had a whiteboard in my bedroom. It was very, very low key. Like we were barely getting by, just doing everything we could to essentially prove that our technology worked and that it had value in applications. And we just took lots of shots on goal. Yeah. And then our second location, once we had Tomas join on, we were working at the Cambridge Innovation Center, which is like a shared co-working space. And Tomas had a basement. So that became the new lab, where we had, he built like a saw for cutting fiberglass into a spring. And that was in the basement at his house. And then we really needed better space. So Techstars had helped us figure out our business model.
Yeah.
And we shifted from being at the Cambridge Innovation Center to being at Techstars, but they didn't have like hardware prototyping space. So then we found through word of mouth, through a good friend, Deckard Sorensen from MVP Nano, Techstars company, in our cohort, we found Greentown Labs. And this was Greentown Labs 2.0 when they were over in the Boston Seaport. And it was still, so there were only like 10 companies there. And I did a tour. I saw that joining them got us SolidWorks for free and MATLAB for free and, like Simulink and like all these like really nice tools for engineering analysis. And then they had a prototyping space, they had an office space. And I think for like $1,000 a month, we got everything. And I could pack like a full team, like our team of 3 at the time. Plus, like, we had 3 interns. We just packed everybody into, like, one little room. Yeah. And we bunkered down there for about a year until Greentown moved. So when Greentown moved over to Somerville, we went with them. And the reason that happened is because the innovation district in Boston just became so expensive, like it usually does. The entrepreneurs moved in first, but then all the other companies, like, moved in next. And before you knew it, like, the rent had gone up. So we moved to Somerville. And we were at Greentown Labs for several years. That was very stable there. Really good deal. Yeah. Had everything we needed. And we stayed there until...
How did you, fund yourselves at this point? Were you getting investment or were you...
Yeah, it was all angel investors and the Techstars program. Yeah. And we just kept our costs as low as we could. Yeah. Like we were just way below. We were just really bootstrapped, even though we were angel funded. Yeah. So we did that for almost 7 years. Yeah. And then what happened is, we're like, actually, I think we can go into hydraulics. And so we started introducing ourselves to hydraulic applications, and we found some dead battery problems in.
So what made you think that you could get into hydraulics?
So we had an accidental discovery late at night at Greentown Labs where we were trying to make air compressors, with a variety of different tensile elements. So like the way our actuator works is there's like effectively a string, if you will, wrapped around a motor shaft that makes it so you go from a spinning motor shaft to a pushing and pulling like rod. Yeah. And so we had tried out all sorts of different constructions of tensile element, right? So we had tried out, like different types of rope material, Kevlar, Vectran, Dyneema. It's a long list of different materials. We tried out different constructions, like twisted and braided. Tried out jackets and overmolds, and we just tried out all sorts of different experiments. And nothing was really working until we finally got into belts. And so we had applied belts to air compressors, and we were doing some reliability testing. And the air compressor reliability testing was going pretty well. I mean, we were past several million cycles. We were close to 10 million. But the problem was the air compressor would go all the way to 100 million. And we were seeing them wear out in a very weird way. And we were kind of stumped. So we called a team meeting, and 4 of us huddled up and we're like, what can we do? So each of us kind of took a different approach here, but we all figured out that the best solution was there was this rope expert named Roland Verriet, who is lovingly called the Rope Pope. And he's just this really smart and good communicating guy that has like a great website with illustrations of all the different technicalities about wire rope. And he had spent a decade as like the head of a wire rope company in like the technical department. So we wrote him a letter and said, we're stumped, we need your help. So we gave him a call and did a video conference. And then he decided that what we were doing was really novel. He'd never seen anything like it. He thought it had a profound probability to really change his industry. And so he flew out here from Germany. He spent a day with us doing a deep dive on how we see the world and all the things we had done. And then the next day he did the seminar that was like custom tailored to like what we were doing. He just gave, in a really nice way, not asking for anything. And, all we did was take him out to lunch and hang out with him, really. And,
well, it's German. They must have had some good beer, though.
Yeah. So we started a new test as a result of this, and we were looking at that test really closely. And there was one spot where we had twisted the belt. And that's a no-no in the land of belts.
Yeah.
Belt makers tell you don't twist the rope, don't misalign the rope, don't twist the belt, don't misalign the belt. Rope makers, they don't care that much about twisting or misaligning because the rope can tolerate it. It can roll and it's round.
Right.
So it just realigns itself. And if it does wear, it wears in a different way. Where like with a belt, it can't tolerate it and it just disintegrates. And so we were seeing this belt failure over and over and over again on our air compressor. And what we figured out was we needed to do less cycles and higher loads. So same type of power, but in a different wear. And then we also figured out, this is where there was a key breakthrough technically. We figured out that essentially in the world of belts, 2 wrongs make a right. In the sense that like if you both twist it and misalign it, that it's kind of as if you had done neither.
Mm.
And so since the belt makers and the whole belt industry teaches you don't do either of those, that's the basis for a patent. I mean, that's the basis for a breakthrough. When you do stuff that is considered heretical, right? Like we became heretics, right? We were doing all the wrong things to belts, and making them last longer, right? So what I'm trying to say here is that our test was going pretty bad until we had an expert come in and educate us. And then late at night, we made an insight into an observation. And so we tweaked our test and we intentionally added in an additional misalignment on top of, we had already made one misalignment. So we just added in another one. And then Blake derived a mathematical proof showing theoretically why this also made sense. And then we ran a whole bunch of experimental test data, and the test data validated the mathematical theory. And that was really the key moment where we knew we had something powerful. So we reduced it to practice. We put it into we shifted from air compressors, which are high. They operate every second.
Yep.
They operate 60 hertz approximately. So they're running like 100 times more often than hydraulics.
Yeah.
And so by switching to hydraulics, we became very competitive against hydraulics compared to pneumatics. We were less competitive.
Sure.
And so then we figured out, okay, well, we should go into the area where hydraulics can't go. And so we found that the hydraulic marketplace had been being transformed through electrification, and specifically ball screws and roller screws, and generally electromechanical linear actuators were nipping away at hydraulic market share around the edges. And they were mostly doing it for the purpose of precision control, as well as increased energy efficiency.
Okay.
And so, you'll see that today in a lot of like heavy machinery, in like the auxiliary movement. There will often be electromechanical linear actuators instead of hydraulics. And so then we were like, well,
is that like the spin like on a excavator or something? Is that what you mean?
No, you see it maybe in like, a lot of times you see it in like it's kind of an unimpressive list.
Yeah.
But it's like seat positioner.
Oh,
like,
okay.
Grain angle chute adjuster.
Right.
Or like not the lifting hard work part, but the adjusting it to the left or the right, just ever so slightly. One of the downsides of screws is they can't really do that many cycles.
Right.
Right. So and they can't do high loads and they can't do high strokes. So they were limited to just auxiliary applications.
Sure.
So there is no electromechanical solution that could go into like the high power, like high force, high stroke, like big, right? Big hydraulics. And even hydraulics themselves kind of top off at like 3 to 6 stories, right? So you get up to like 60 feet. And that's just a very large tube, right? So around 60 feet, it switches over again into the world of cables.
Mm-hmm.
So if you look at really big machinery, bigger than like 60 feet, it's cable driven, right?
Yeah.
So cranes are cable driven, and excavators that dig are hydraulic driven.
Yeah.
So we found this really interesting spot, which is basically the biggest hydraulic cylinders that need precision or need to be more efficient would really benefit from an electromechanical air actuator. But nobody else can do it, and we could. And so with our new learning about what to do with our belt, we focused specifically on the hydraulic precision and battery, like heavy duty sector. And we found that it made a lot of sense in lift gates, especially given that electric trucks are coming.
Mm-hmm.
And the problems that exist right now in lift gates, they're bad, but they are getting much worse as you switch to an electric truck.
Right, because the batteries go.
Yeah, your battery problem just gets bigger.
Yeah.
Because diesel is incredibly energy dense. It's like 1,000 times more energy dense than a battery.
Yeah.
And so if you switch away from diesel to a battery, then problems that didn't exist start to show up.
Yeah.
Like dead batteries. Right?
Sure.
So, like for example, we've heard that electric garbage trucks, which are currently hydraulic over electric, the hydraulics are so inefficient that these electric batteries in these trucks, they can't do a full shift, right? Mm-hmm. They can't run the same route, right? So instead of buying one diesel garbage truck, you have to buy like 2 battery electric garbage trucks to do the same pickup route. So that's a problem.
Right, of course.
Right. So the dead battery problem actually turns into a more machines problem, which generally is just larger cost.
So with that, you have a new partnership with Anthony Liftgates.
Yeah.
And RISE is inside. Tell me a little bit about, what the partnership is and what it means for the future of RISE now.
Yeah, Anthony's a very innovative company, and they were one of the original liftgate companies, and they actually were the early adopter of hydraulics. Mm-hmm. So back when hydraulics were new, Anthony was like the first to apply it to dumping and loading and lifting. And then they were keenly aware of the battery problems in their industry. They had been thought leaders on that. And so they joined us, and together we tested our technology in their liftgate. And at the real moment of proof where we all got very excited was we did a side-by-side test of the RISE inside Anthony liftgate with the hydraulic liftgate. And we were doing, even in the worst case scenario for RISE, we were doing better than triple the number of lifts per battery charge. And in the best case scenario, it's effectively infinite, right? Because what I mean by that is RISE technology actually regenerates power when you lower a load. So if you're delivering, a couple pallets of soda, they'll actually produce more energy lowering those pallets to the ground than you consume when you're raising an empty liftgate, right? Mm-hmm. Because you don't lift up the same load that you lower. You're making a delivery. So you lower the load, the soda goes inside the store, mm-hmm. and then the liftgate goes back up to the truck empty. So they really should actually be called lower gates, not lift gates, because they're not really lifting.
Right.
They're lowering.
Right.
Their whole purpose is to go from a dock to retail,
sure.
to ground level. If they could just go from dock to dock, they don't need a lift gate.
Right.
Right. And so, you kind of think about what a lower gate means with hydraulics. Lowering uses energy.
Yeah.
Lifting uses energy too, but lowering uses energy. With RISE, the lowering actually uses energy. And so there's a very real possibility that busy, heavy delivery routes, liftgates that have RISE inside, so Anthony liftgates will be charging the truck battery every time they make it deliver.
Yep.
So that was really exciting for everybody. And so we leaned all the way into it, and now we're going into production and launching these with limited, early adopter trucking fleets.
Yeah, absolutely. So, what does that mean, for RISE and like timing, or, when does delivery when is delivery expected? And I can feel the energy in the building, just walking in as everybody's kind of pulling in the same direction.
Yeah, the production begins at the end of this month, and then we're going to be working out those low production issues that always occur anytime you set up a new production line.
Yeah.
So we'll have a limited stable production in September, and we'll be rolling out our earliest production units to Anthony's most innovative customers. And then after, a reasonable amount of time, probably about a month or so, we'll be increasing production with more of the same. And from there, I think it's really about just managing production to keep up with orders, right? We haven't launched a production unit at RISE before. The team that we've built now. So we were just 4 people for 7 years. And now we're about 20 people.
Right.
And we've added operational experience. We've added manufacturing experience, production, testing. We really transformed the company. It's doubled twice in the last 2 years.
Which is really saying a lot considering what we've just gone through.
Yeah.
And all the challenges. But, supply chain needs it now more than ever.
Yeah, they really do. The supply chain is a huge backlog. They're incredibly busy. There's a couple of trends that are driving growth, which is, e-commerce is driving growth. Distribution centers with retail is changing, increasingly for lift gates as well as general material handling. More than ever, people are picking things up and setting them down all across the whole supply chain. And then the last trend is the need for zero emission electric trucks is really catalyzing the need for better batteries.
Mm-hmm.
And while everybody else is waiting on better batteries, we effectively have a battery solution that can double, triple, or even 10 times the battery performance. So lift gates are going to market now, and we're going to soon announce another partnership in forklifts.
Yeah.
Where, we can be using as little as 1/10 of the energy of hydraulics in the largest forklifts in the world.
That's so exciting. Well, man, I know you're busy. Thank you so much for taking the time today. The future looks amazing for RISE, and we're just thankful to be a small part of that. So, Arron, thanks for joining me today.
It's been fun.
You have been listening to the RISE Inside podcast, presented by RISE Robotics. On behalf of our guest today and host Justin Starbird, thank you for listening. Please share your feedback on our LinkedIn page, linkedin.com/company/RISE-robotics.